Okay, so some of your questions will look like this. Use all of the tools in your toolbox to find the real zeros of a polynomial. The rational zero theorem, that's where we would normally start from. We would write down our possible rational zeros. Descartes' rule of signs is a tool that tells us how many possible positive and negative real zeros there are, but it's still kind of sketchy, just gives us a little better idea. And upper and lower bounds, as you're doing your synthetic division, the upper and lower bounds can be found, so you know when to stop going higher or when to stop going lower with your numbers when you're guessing and checking. Okay, those are things that are in our toolbox. But another thing that's in your toolbox, so I'm not going to go through those two rules, is a graphing calculator. Okay, I know sometimes it takes a while to get used to, but in this instance, very helpful. So if we were asked to find all of the real zeros of this function here, x to the third minus 21x minus 20, if I were to graph that on the calculator, my zeros are the places where it crosses the x-axis, the x values. Okay, so notice I have graphed this function, and this is what it came out as on my graphing calculator. I can very clearly see exactly what my zeros are. They are exactly on, and you may want to use the trace tool just in case. If they're on integers, which these are, this one is crossing exactly at -1. This one is crossing at exactly -4. And this one is crossing at exactly 5. So I know right away that my zeros are -4, -1, and 5. You may want to check them just to make sure, okay? Is this all of my zeros? That's one question you would want to ask. Maybe there's other imaginary zeros, which in this lesson we're just worried about the real zeros, okay? So the real zeros should show up on your graph. This was a degree 3 polynomial, so it can have 3 zeros, okay? And it won't always have exactly 3 real zeros, but in this case it does. It can't have any more than that because it's only degree 3. So I know I have my answer, okay? My zeros are at -4, -1, and 5. So just like that, plugged it into a calculator, and I could see exactly where those were crossing. Now, where you have to be careful is if they do not cross at an exact integer. These crossed exactly at those marks, okay? If it's between 2, then we have to do a little more work. All right, here is another example. We are asked to find the zeros of p of x equals 2x to the third plus 5x squared minus 4x minus 3. Okay, let's check to see if we have some exact zeros. It appears this one crosses at exactly 1. Okay, so again, all I did, I plugged the function in my calculator. Watch your numbers carefully, and you should be okay. This one crosses at exactly -3. Okay, these are zeros because it's the numbers that make y, or p of x, equals 0. This one looks like it's about -1/2, but anytime it crosses in between, you want to do a little work just to make sure. So on this one, it wants the zeros. I know that -3 is one of my zeros. I know that 1 is one of my zeros. I am going to, just to be safe, I'm going to check something out to see if this is 1/2. Excuse me, -1/2. So remember that in our last Unit 4, Assignment 2 lesson, we talked about checking to see if something is a zero, and we talked about the fact that if you do synthetic division and come out with a remainder of 0, then yes, it is. So I'm just going to check this one. Remember synthetic division, we drop the first number straight down, and then we multiply. -1/2 times 2 is -1. 5 minus 1 is 4. -1/2 times 4 is -2. And then I add those. -4 and -2 gives me -6. And I multiply again. -1/2 times -6 is +3. -3 plus +3 is 0. Okay, so it is in fact at -1/2. If it had not been, and we'll do some like this, then we'll talk about other steps you can take. So I know that negative 1/2 is in fact my third zero, okay? Okay, we will have some that aren't going to work out quite that nice. But again, graphing is nice because it shows you a picture and lets you find some of those zeros. Okay, again, they're giving me these instructions to use my toolbox, but I want you to not forget that graphing is one of your tools in the toolbox also. So I graphed this function on a graphing calculator, and here is the graph that I got back. I look for zeros, which are places it crosses the x-axis, which it looks like here at -2 is where that happens for this one. At this point, I only have -2. All right, I don't see it crossing anywhere else. So let's do some investigation and see maybe what happened to the other zeros. It's degree 3, so it's going to have it can have 3 zeros. Let's see maybe what happened to the others. So what I'm going to do is break down the polynomial a little bit. Right now I know my answer is just -2. That's the only real zero on this graph. But I'm going to break this down a little bit to see and kind of analyze what happened. So again, I'm going to do synthetic division. Remember, you write down the coefficient of each term, and we're dividing -2 in. I'm doing that because I know -2 is a zero. I'm going to bring the 1 straight down. Multiply, -2 times 1 is -2, and then you add straight down, 1 and -2 is -1, and we multiply, -2 times -1 is a +2, and we add 1 plus 2 is 3, -2 times 3 is -6, and I get a remainder of 0, which verifies, yes, -2 was one of my zeros. Now, the reason we did that was to break our polynomial down 1 degree. Okay, we divided, and that drops us 1 degree to an x² function. And to know what the x² function is, we use our answers that came out here at the bottom. So we have 1x² minus 1x plus 3. Now, if we were to try to find the zeros of this, what would we get? It's a quadratic, which we loved those because they either factored or you could use the quadratic formula. This doesn't factor. So if I tried the quadratic formula, my a is 1, my b is -1, and my c is 3. So I have 1 plus or minus the square root of -1 squared minus 4 times 1 times 3. If you don't have the quadratic formula memorized, hopefully you have it written down somewhere because it is used frequently. Okay, so I have 1 plus or minus the square root of 1 squared is 1, minus 12 over 2, and as we simplify this, you can see what happened to those other zeros, because here 1 minus 12 gives me a -11, which makes this the square root of -11 and would make that an imaginary zero. They only wanted the real zeros. Imaginary zeros don't show up on the graph. Okay, so that would give me 2 more zeros, but they're imaginary and aren't part of my answer. So that's something you can do to just check and make sure you have everything you need on your graph. Again, these zeros that we solved for here will come into play in our next unit or our next lesson. But in this case, we only want real zeros, so our answer is just -2. All right, next question. Again, we're asked to find the zeros of this function, and so I graphed it, and here's my graph. I look for places it crosses, and I notice it crosses here, maybe somewhere around here, and then it crosses here. Okay? Now, when I do that, I notice that I can't really see where those zeros are because they're somewhere in between. So what I want to do is go ahead and check what's happening. The zero I can see is right here. I know it crosses at 0, so that's my given. So I look at my function and I say, what can I do to try and solve this? Okay, algebraically, when we were finding zeros, remember we set the function equal to 0 and tried to solve. Well, notice each of these has an x in it. In fact, they have at least an x squared. So my first step would be to factor out any common factors. I can take an x squared out of each term, and I'm left with 5x squared minus 2x minus 1. I could also use synthetic division to break it down, okay, but this is another option. Now, as I set each of those factors equal to 0, I notice that 0 is an answer twice, multiplicity 2, which is why it touches at 0 instead of crossing, okay, like we learned it would. Okay, so 0, multiplicity 2. And over here, I want to find the other zeros, because I can't tell exactly where they cross. So I'm going to do a little work, because they want exact answers and not decimals. So even if I use my tracing tool, I would just get a decimal instead of an exact answer for them. This is quadratic, which is good news. If I can factor, I would go ahead and factor that. If it doesn't, I'm going to use the quadratic formula. This does not factor, so we are going to use our quadratic formula, negative b. My b is negative 2, plus or minus the square root of b squared, minus 4 times my a, which was 5, times my c, which was negative 1, all over 2 times a, which was 5. If I simplify that, I get 2 plus or minus the square root of 4 plus 20, which is 24. You want to watch your signs carefully. Make sure you do that correctly. Those negatives can mess you up if you're not careful. So I have 2 plus or minus the square root of 24 over 10, and I want to simplify if at all possible. I can simplify. I don't know if you remember from Algebra 2, but when you simplify radicals, you take out any perfect squares you can. And since 24 is the same as 4 times 6, and 4 has a square root of 2, I can simplify this as, if you need help with that, give me a call. We'll talk about it. Okay? I can simplify this as 2 root 6, because again, 24 is 4 times 6. The square root of 4 is 2, so I could bring that out. 6 doesn't have a whole number square root, so it stays in. And then I simplify that. 2 divides into each of these, 1, 1, and 5. So my other two zeros are 1 plus or minus the square root of 6 over 5. You can separate those if you want as 1 plus the square root of 6 over 5 and 1 minus the square root of 6 over 5. But here are my real zeros. This was degree 4, and notice all of them happen to be real. I had 0, multiplicity 2, so that counts twice. And then I had 2 more here, 1 plus the square root of 6 over 5 and 1 minus the square root of 6 over 5. So I found all of those real zeros. Again, graphing helps me a lot because I didn't have to just guess and check. Okay, I was able to see exactly where zeros were.